This handbook describes the various environmental conditions affecting human survival and describes isolated personnel, activities necessary to survive during successful evasion or isolating events leading to successful recovery. It is the fundamental reference document providing guidance for any USAF service member who has the potential to become isolated. Deviations require sound judgment and careful consideration. This publication provides considerations to be used in planning and execution for effective mission accomplishment of formal USAF survival, evasion, resistance, and escape, SERE, training, environmentally specific SERE training, and combat survival continuation training programs. The tactics, techniques, and procedures in this publication are recognized best practices presenting a solid foundation to assist USAF service members to maintain life and return with honor from isolating events. IP in a survival situation have needs which must be met, including food, water, clothing, shelters, etc. The survival kit contains equipment which can be used to satisfy these needs. Quite often, however, this equipment may not be available due to damage or loss. This chapter will address the care and use of issued equipment and improvising the needed equipment when not available. The uses of some issued items are covered in appropriate places throughout this handbook. The care and use of equipment, not covered elsewhere, will be addressed here. Electronic signaling devices are by far the IP's most important signaling devices. Therefore, it is important for IP to properly care for them and any spare batteries to ensure their continued effectiveness. In cold temperatures, electronic devices must be kept warm to prevent the batteries from becoming cold-soaked, decreasing their lives. In a cold environment, if IP speak directly into a microphone, the moisture from their breath may condense and freeze on the microphone, creating communication problems. Caution must be used when using radios in a cold environment. If the radio is placed against the side of the face to communicate, frostbite could result. In a wet environment, IP should make every effort to keep their electronic signaling devices dry. In an open sea environment, the only recourse may be to shake the water out of the microphone before transmitting. In an extreme heat environment, batteries have a tendency to overheat and IP need to take steps to keep the radio cool. Keep electronic devices out of direct sun and next to the body while not in use. A firearm is a precision tool. It will continue functioning only as long as it is cared for. Salt water, perspiration, dew, and humidity can all corrode or rust a firearm until it is inoperable. If immersed in salt water, the IP should wash the parts in fresh water and then dry and oil them if possible. Also, any firearms should be stored outside of shelters to prevent condensation from building on the weapon, which could lead to malfunctions. Many petroleum-based lubricants used in cold environments will stiffen or freeze, causing the firearm to become inoperative. It would be better to thoroughly clean the firearm and remove all lubricant. Metal becomes brittle from cold and internal firing mechanisms may be more prone to breakage. A firearm was not intended for use as a club, hammer, or pry bar. To use it for any purpose other than for which it was designed would only result in damage to the firearm. One of the most valuable items in any survival situation is a knife, since it has numerous uses. A file or sharpening stone should be packed in the personal survival kit. The file is normally used for axes, and the stone is normally used for knives. Control of a cutting tool is easier to maintain if it is sharp, and the possibility of accidental injury is reduced. A knife should be sharpened only with a stone, as repeated use of a file rapidly removes steel from the blade. In some cases, it may be necessary to use a file to remove plating from the blade before using the stone. One of two methods should be used to sharpen a knife. One method is to push the blade down the stone in a slicing motion. Then turn the blade over and draw the blade toward the body. The other method is to use a circular motion the entire length of the blade, turn the blade over and repeat the process. What is done to one side of the cutting edge should also be done to the other to maintain an even cutting edge. If a commercial whetstone is not available, a natural whetstone can be used. Water should be applied to these stones. The water will help to float away the metal removed by sharpening and make cleaning of the stone easier. Any sandstone will sharpen tools, but gray, clay-like sandstone gives better results while quartzite should be avoided. IP can recognize quartzite instantly by scratching the knife blade with it. The quartz crystals will bite into steel. If no sandstone is available, granite or crystalline rock can be used. If granite is used, 2 pieces of the stone should be rubbed together to smooth the surface before use. As with a knife, a sharp axe will be safer and save time and energy. A file should be used on an axe or hatchet. The IP should file toward the cutting edge, but care must be taken to avoid slipping and cutting yourself. The file should be worked from one end of the cutting edge to the other. The opposite side should be worked to the same degree. This will ensure that the cutting edge is even. After using a file, the stone may be used to hone the axe blade. When using an axe, don't try to cut through a tree with one blow. Rhythm and aim are more important than force. Too much power behind a swing interferes with aim. When the axe is swung properly, its weight provides all the power needed. Carving a new axe handle and mounting the axe head takes a great deal of time and effort. For this reason, IP should avoid actions which would require the handle to be changed. Using aim and paying attention to where the axe falls will prevent misses which could result in a cracked or broken handle. IP should not use an axe as a pry bar and should avoid leaving the axe head in cold weather where the handle may become brittle. A broken handle is difficult to remove from the head of the axe. Usually the most convenient way is to burn it out. For a single bit axe, bury the bit in the ground up to the handle, and build a fire over it. For a double bit, an IP should dig a small trench, lay the middle of the axe head over it, cover both bits with earth, and build the fire. The covering of earth keeps the flame from the cutting edge of the axe and saves its temper. A little water added to the earth will further ensure this protection. When improvising a new handle, an IP can save time and trouble by making a straight handle instead of a curved one like the original. IP should use a young, straight piece of hardwood without knots. The wood should be whittled roughly into shape and finished by shaving. A slot should be cut into the axe head end of the handle. After it is fitted, a thin, dry wooden wedge can then be pounded into the slot. IP should use the axe for a while, pound the wedge in again, and then trim it off flush with the axe. The handle must be smoothed to remove splinters. The new handle can be seasoned to prevent shrinkage by scorching it in the fire. When whittling, IP must hold the knife firmly and cut away from the body. Wood should be cut with a grain. Branches should be trimmed as shown, trimming branches. To cut completely through a piece of wood, a series of V-cuts should be made all the way around as in. Once the piece of wood had been severed, the pointed end can then be trimmed. The thumb can be used to help steady the hand. Be sure and keep the thumb clear of the blade. To maintain good control of the knife, the right hand is steadied with the right thumb while the left thumb pushes the blade forward. This method is very good for trimming. To fell a tree, the IP must first determine the direction in which the tree is to fall. It is best to fell the tree in the direction in which it is leaning. The lean of the tree can be found by using the axe as a plumb line. The IP should then clear the area around the tree from underbrush and overhanging branches to prevent injury. The IP should make 2 cuts. The first cut should be on the leaning side of the tree and close to the ground, and the second cut on the opposite side and is slightly higher than the first cut. Falling trees often kick back and can cause serious injury, so IP must ensure they have a clear escape route. When limbing a tree, start at the base of the tree and cut toward the top. This procedure will allow for easier limb removal and results in a smoother cut. For safety, the IP should stand on one side of the trunk with the limb on the other. To prevent damage to the axe head and possible physical injury, any splitting of wood should be done on a log as in Figure 1511. The log can also be used for cutting sticks and poles. Cutting poles. If a shoot equipment is inoperative, insufficient, or non-existent, IP will have to rely upon their ingenuity to manufacture the needed equipment. IP must determine whether the need for the item outweighs the work involved to manufacture it. They will also have to evaluate their capabilities. If they have injuries, will the injuries prevent them from manufacturing the items? IP should follow 5 basic rules of improvising to meet their needs using a logical problem-solving technique. The 5 rules are: 1. Determine the need. Needs are determined by the IP situation and prioritization. See Chapter 1, 2, 3. 2. Inventory materials, both man-made and natural. Consider using abundant natural materials and avoid wasting limited materials. 3. Consider alternatives, brainstorm and list possible solutions. 4. Select the best alternative based on time, energy, and materials. 5. Plan and construct making the best use of materials and ensuring it is safe and durable. Undue haste may not only waste materials, but also waste the IP's time and energy. Before manufacturing equipment, they should have a plan in mind. The IP's equipment needs may be met in 2 different ways. They may alter an existing piece of equipment to serve more than one function, or they may construct a new piece of equipment from available materials. Since the items IP can improvise are limited only by their ingenuity, all improvised items cannot be covered in this document. The methods of manufacturing the equipment referred to in this handbook are only ideas and do not have to be strictly adhered to. Aircrew members may have a parachute. This device can be used to improvise a variety of needed equipment items. The pilot chute deploys first and pulls the rest of the parachute out. The parachute canopy consists of the apex, top, and the shirt or lower lateral band. A typical C9 parachute canopy is divided by radial seams into 28 sections called gores. Each gore measures about 3 feet at the skirt and tapers to the apex. Each gore is further subdivided into 4 sections called panels. The canopy is normally divided into 4 colors. These colored areas are intended to aid the IP in shelter construction, signaling, and camouflage. 14 suspension lines connect the canopy material to the harness assembly. Each piece of suspension line is 72 feet long from riser to riser and 22 feet long from riser to skirt and 14 feet from skirt to apex. The tensile strength of each piece of suspension line is 550 pounds. Each piece of suspension line contains 7 to 9 pieces of inner core with a tensile strength of 35 pounds. The harness assembly contains risers and webbing, buckles, snaps, D-rings, and other hardware which can be used in improvisation. The whole parachute assembly should be considered as a resource. Every piece of material and hardware can be used. To obtain the suspension lines, an IP should cut them at the risers or, if time and conditions permit, consider disassembling the connector links. Cut the suspension lines about 2 feet from the skirt of the canopy. When cutting suspension lines or dismantling the canopy, pack assembly, it will be necessary to maintain a sharp knife for safety and ease of cutting. IP should obtain all available suspension line due to its many uses. Even the line within the radial seams of the canopy should be stripped for possible use. The suspension line should be cut above the radial seam stitches next to the shirt end of the canopy, 2 places. The cut should not go all of the way through the radial seam. At the apex of the canopy, and just below the radial seam stitching, a horizontal cut can be made and the suspension line extracted. The line can then be cut. For maximum use of the canopy, IP must plan its disassembly. The quantity requirements for shelter, signaling, etc., should be thought out and planned for. Once these needs have been determined, the canopy may be cut up. The radial seam must be stretched tightly for ease of cutting. The radial seam can then be cut by holding the knife at an angle and following the center of the seam. With proper tension and the gentle pushing, or pulling, of a sharp blade there will be a controlled splitting of the canopy at the seam. It helps to secure the apex either to another individual or to an immobile object such as a tree. One requirement in improvising is having material available. When stripping the harness assembly, the seams of the webbing should be split so the maximum usable webbing is obtained. The harness material and webbing should not be randomly cut as it will waste much needed materials. Parachute fabric, harness, suspension lines, etc., can be used for clothing. Needles are helpful for making any type of emergency clothing. Wise IP should always have extra sewing needles hidden somewhere on themselves. If no sewing needles are available, a good needle or sewing awl can be made from a sliver of bone. Thread is usually available in the form of inner core. It will benefit the IP to collect small objects which may come in handy. Wire, nails, buttons, a piece of canvas, or animal skin should not be discarded. Any such object may be worth its weight in gold when placed in a hip pocket or a sewing kit. Any kind of animal skin can be used for making clothing such as gloves or mittens or making a ground cover to keep the sleeping bag dry and clean. Small skins can be used for mending and for boot insoles. Mending and cleaning clothes when possible will pay dividends in health, comfort, and safety. The improvised equipment IP may need to make will probably involve sewing. IP knowledge of hand stitching may be critical in improvising or repairing articles of clothing and making multi-use equipment. Knowing and understanding the proper stitch to use is important to the item's function and longevity. Depending on the stitch, its use, and the type of thread, some techniques require double thread sewing on an improvised button or securing an item to a piece of material, but most are worked with a single thread. A well-made hand stitch will be secured at beginning, ending with no loose threads, and be smooth and not create puckers on the outer or inner sides of the fabric. Thread can be obtained from untwining line, inner core of a parachute line, pulling a line apart from rip material, tree bark, or even repurposed from fishing line, dental floss, metal wire, etc. Sinew can also be used especially with natural materials such as rawhide and brain tanned buckskin. Stronger than any thread, sinew is used in both fine and heavy applications, from sewing to making bows and rope. Genuine sinew used as thread can be prepared wet or dry. The same technique for separating a strand can be applied to a dry piece of sinew, taking only the thread that you will use at the moment. However, soaking in water until pliable and preparing threads ahead of time may be an easier method of improvising. 1. Soak the sinew piece in room temperature water until soft and pliable. 2. Grasp the new sinew by the sides and begin working it with your hands in a twisting motion back and forth until the fibers begin to separate. This will take some work as the fibers are held together by natural glues. 3. Peel strands one at a time from the piece in the thickness you desire. 4. While still wet and pliable, hold the end of a strand in the fingertips of one hand while rolling the strand down the top of your thigh to twist it. Put a knot in one end and form the other end into a pointed tip. Twisting and knotting the strand while still wet allows you to work the sinew easily. 5. These dried threads are now ready for sewing. Techniques include pre-punching the material with an awl, then pushing the sinew's pointed tip through, or threading the strand through a conventional, improvised needle. If pre-punching the material with an awl then pushing the thread through the material will not work, the IP will have to use some type of needle. The first needles were made of bone or wood. Needles for hand sewing have a hole, called the eye, at the non-pointed end to carry thread or cord through the fabric after the pointed end pierces it. IP can improvise a needle or an awl-type tool from scrap metal, bone, and/or wood. Yucca leaves can be pulled sharply up and then peeled down, leaving the plant fibers attached to the tip of the leaf, creating a threaded needle which can be used. When putting needles in personal survival kits, it is always recommended to pack them already threaded. Sewing with fur, whether real or faux, is a bit different from sewing with fabric. Cut the fabric in a single layer, cut only through the backing. Smooth the fur or pile away from the stitching line toward the fabric right side. A whip stitch is recommended. To sew anything by hand, begin by knotting the thread to your fabric, make a slip knot. Run the thread through a small section of the fabric, slip the needle through the slip knot hole, and then pull everything tight. The thread should now be fastened. Another way to knot your fabric is to slip the needle into the fabric to create a loop, and then slip the needle through the loop. Pull the loop tight, and repeat to make a second knot. Backstitch is the strongest hand stitch for 2 pieces of standard cloth material. Work backstitch from right to left. 1. Lay the 2 pieces of fabric you wish to join with either the right or the wrong sides facing. Right sides facing will create an invisible stitch, wrong sides facing will create a visible stitch. 2. Thread a sewing needle and attach the thread to the right-hand edge of the first piece of fabric using whatever method you prefer. 3. Begin with a couple of stitches worked on the spot, and then take a stitch in a space. 4. Take the needle back over the space and bring it out the same distance in front of the thread. 5. Continue to the end of the seam. Fasten off with a couple of stitches on the spot. The whip stitch is commonly used to attach two pieces of material or finish hem something. It works very well on thicker or stiffer material. The whip stitch is an overhand technique in which the needle enters the fabric from below and exits from above for every stitch worked. 1. Lay the two pieces of fabric you wish to join with either the right or the wrong sides facing. Right sides facing will create an invisible stitch, wrong sides facing will create a visible stitch. 2. Thread a sewing needle and attach the thread to the right-hand edge of the first piece of fabric using whatever method you prefer. 3. Insert the needle through the second piece of fabric and pull the thread tight. 4. Bring the needle back to the first piece of fabric by laying the thread over the seam. 5. Insert the needle through both pieces of fabric, beside and approximately 1/16 of an inch over from where the needles was inserted the first time. The second stitch will enter the first piece of the fabric beside the first stitch, with the thread wrapping over the top of the seam with each stitch. 6. Repeat steps 4 and 5 until you come to the end of the row, whipping the thread over the top of the seam with every stitch. 7. Tie off your thread at the end of the row by inserting your needle back under the previous whip stitch and pulling the thread almost all the way through. When you have only a small loop of thread left, insert the needle through the center of the loop and pull it tight to create a knot. Cut off any remaining thread just past the knot. The material to be sewn may be quite thick and hard to sew. If this is the case, a palm-type thimble can be improvised to keep from stabbing fingers and hands. Figure 15-17. A piece of webbing, leather, or other heavy material, with a hole for the thumb, can be used. A flat rock, metal, or piece of wood can be used as the thimble, and this is held in place by a donut-shaped piece of material sewn onto the palm piece. To use, the end of the needle with the eye is placed on the thimble and the thimble is then used to push the needle through the material to be sewn. The snowshoe frame can be made from a sapling 1 inch in diameter and 5 feet long. The sapling should be bent and spread to 12 inches at the widest point. The IP can then include the webbing of suspension lines. The foot harness, for attaching the snowshoe to the boot, is also fashioned from suspension line or other cord. A sapling can be held over a heat source and bent to the shape shown in. Wire from the aircraft or vehicle, parachute suspension line or other cord can be used for lashing and for making webbing. Snowshoes can also be quickly improvised by cutting a few pine boughs and lashing them together at the cut ends. The lashed boughs positioned with the cut ends forward can then be tied to the feet. Bow snowshoes. IP should guard against frostbite and blistering while snowshoeing. Due to the design of the harness, the circulation of the toes is usually restricted, and the hazard of frostbite is greater. IP should check the feet carefully by stopping often, taking off the harness, and massaging the feet when they seem to be getting cold. Blistering between the toes or on the ball of the foot is sometimes unavoidable if a good deal of snowshoeing is done. To make blisters less likely, the IP should keep socks and insoles dry and change them regularly. Rawhide is a very useful material which can be made from any animal hide. Processing rawhide is time-consuming, but the material obtained is strong and very durable. It can be used for making sheaths for cutting tools, lashing materials, ropes, etc. The first step in making rawhide is to remove all of the fat and muscle tissue from the hide. The large pieces can be cut off and the remainder scraped off with a dull knife or similar instrument. The next step is to remove the hair. This can be done by applying a thick layer of wood ashes to the hair side. Ashes from a hardwood fire work best. Thoroughly sprinkle water all over the ashes. This causes light to leach out of the ash. The lye will remove the hair. The hide should be rolled with the hair side in and stored in a cool place for several days. When the hair begins to shed, check by pulling on the hair. The hide should be unrolled and placed over a log. Remove the hair by scraping it off with a dull knife. Once the hair is removed, the hide should be thoroughly washed, stretched inside a frame, and allowed to dry slowly in the shade. When dry, raw hide is extremely hard. It can be softened by soaking in water. Wire or pieces of metal can be used to replace broken issued saws. With minor modifications, the IP can construct a usable saw. Figure 1521. A bucksaw arrangement will help to prevent the blade from flexing. If a more durable saw is required and time permits, a bucksaw may be improvised. Blade tension can be maintained by use of a tightening device known as a windlass. Tins can serve as adequate cooking utensils. If the end has been left intact, use a green stick long enough to prevent burning the hand while cooking. If the side has been left intact, a forked stick may be used to add support to the container. A basic knowledge of correct rope and knot procedures will aid the IP in doing many necessary actions. Such actions as improvising equipment, building shelters, assembling packs, and providing safety devices entail the use of proven techniques. Tying a knot incorrectly could result in ineffective improvised equipment, injury, or death. For a depiction of the following rope terminology: a bend, called a knot in this handbook, is used to fasten two ropes together or to fasten the rope to a ring or loop. A bight is a bend or U-shaped curve in a rope. A hitch is used to tie a rope around a timber, pipe, or post so that it will hold temporarily but can be readily untied. A knot is an interlacement of the parts of bodies, as cordage, forming a lump or knot or any tie or fastening formed with a cord, rope, or line, including bends, hitches, and splices. It is often used as a stopper to prevent a rope from passing through an opening. A line, sometimes called a rope, is a single thread, string, or cord. A loop is a fold or doubling of the rope through which another rope can be passed. A temporary loop is made by a knot or a hitch. A permanent loop is made by a splice or some other permanent means. An overhand loop is made when the running end passes over the standing part. The rope, often called a line, is made of strands of fiber twisted or braided together. A round turn is the same as a turn, with the running end leaving the circle in the same general direction as the standing part. The running end is the free or working end of a rope. The standing end is the balance of the rope, excluding the running end. A turn describes the placing of a rope around a specific object such as a post, rail, or ring with the running end continuing in the opposite direction from the standing end. An underhand turn or loop is made when the running end passes under the standing part. The raw, cut end of a rope has a tendency to untwist and should always be knotted or fastened in some manner. Whipping is one method of fastening the end of the rope. This method is particularly satisfactory because it does not increase the size of the rope. The whipped end of a rope will still thread through blocks or other openings. Before cutting a rope, place two whippings on the rope 1 or 2 inches apart and make the cut between the whippings. This will prevent the cut ends from untwisting immediately after they were cut. A rope is whipped by wrapping the end tightly with a small cord. Make a bight near one end of the cord and lay both ends of the small cord along one side of the rope. The bight should project beyond the end of the rope about 1/2 inch. The running end of the cord should be wrapped tightly round the rope and cord starting at the end of the whipping, which will be farthest from the end of the rope. The wrap should be in the same direction as the twist of the rope strands. Continue wrapping the cord around the rope, keeping it tight, to within about 1/2 inch of the end. At this point, slip the running end through the bight of the cord. The standing part of the cord can then be pulled until the bight of the cord is pulled under the whipping and cord is tightened. The ends of cord should be cut at the edge of the whipping, leaving the rope end whipped. The overhand knot is the most commonly used and the simplest of all knots. An overhand knot may be used to prevent the end of a rope from untwisting, to form a knot at the end of the rope, or as a part of another knot. To tie an overhand knot, make a loop near the end of the rope and pass the running end through the loop, pulling it tight. The square knot is used for tying two ropes of equal diameter together to prevent slippage. To tie the square knot, lay the running end of each rope together but pointing in opposite directions. The running end of one rope can be passed under the standing part of the other rope. Bring the two running ends up away from the point where they cross and crossed again. Once each running end is parallel to its own standing part, the two ends can be pulled tight. If each running end does not come parallel to the standing part of its own rope, the knot is called a granny knot, figure 1528. Because it will slip under strain, the granny knot should not be used. A square knot can also be tied by making a bight in the end of one rope and feeding the running end of the other rope through and around this bight. The running end of the second rope is routed from the standing side of the bight. If the procedure is reversed, the resulting knot will have a running end parallel to each standing part, but the two running ends will not be opposite each other. This knot is called a thief knot, figure 1528. It will slip under strain and is difficult to untie. A true square knot will draw tighter under strain. A square knot can be untied easily by grasping the bends of the two bights and pulling the knot apart. Granny and thief knots. The use of a single sheet bend, sometimes called a weaver's knot, is limited to tying together two dry ropes of unequal size. It is also useful for joining different materials like cloth or plastic sheeting to make cordage, which could be useful to an IP in an urban evasion, escape or isolating event. To tie the single sheet bend, the running end of the smaller rope should pass through a bight in the larger rope. The running end should continue around both parts of the larger rope and back under the smaller rope. The running end can then be pulled tight. This knot will draw tight under light loads but may loosen or slip when the tension is released. The double sheet bend works better than the single sheet bend for joining ropes of equal or unequal diameter, joining wet ropes, or for tying a rope to an A. It will not slip or draw tight under heavy loads. To tie a double sheet bend, a single sheet bend is tied first. However, the running end is not pulled tight. One extra turn is taken around both sides of the bight and the larger rope with the running end for the smaller rope. Then tighten the knot. The figure 8 knot is used to form a larger knot than would be formed by an overhand knot at the end of a rope. A figure 8 knot is used in the end of a rope to prevent the ends from slipping through a fastening or loop in another rope. To make the figure 8 knot, make a loop in the standing part, pass the running end around the standing part back over one side of the loop, and down through the loop. The running end can then be pulled tight. The bowline is a useful knot for forming a loop in the end of a rope. It is also easy to untie. To tie the bowline, the running end of the rope passes through the object to be affixed to the bowline and forms a loop in the standing part of the rope. The running end is then passed through the loop from underneath and around the standing part of the rope, and back through the loop from the top. The running end passes down through the loop parallel to the rope coming up through the loop. The knot is then pulled tight. The double bowline with a slip knot is a rigging used by tree surgeons who work alone in trees for extended periods. It can be made and operated by one person and is comfortable as a sling or bosun's chair. A small board with notches as a seat adds to the personal comfort of the user. To tie a double bowline, the running end of the line should be bent back about 10 feet along the standing part. The bight is formed as the new running end and the bowline tied as described and illustrated in. The new running end or loop is used to support the back and the remaining two loops and support the legs. Bosun's chair. The butterfly is used to form a non-slipping loop in the rope. To make the butterfly, form a bight in the running end of the rope. Hold this bight in the left hand and form a second bight in the standing part of the rope. The right hand is used to pass bight over bight. Holding all loops in place with the left hand, the right hand is inserted through bight behind the upper part of bight. The bottom of the first loop is grasped and pulled up through the entire knot, pulling it tight. A half hitch is used to tie a rope to a timber or to another larger rope. It is not a very secure knot or hitch and is used for temporarily securing the free end of the rope. To tie a half hitch, the rope is passed around the timber, bringing the running end around the standing part, and back under itself. The timber hitch is used for moving heavy timbers or poles. To make the timber hitch, a half hitch is made and similarly the running end is turned about itself at least another time. These turns must be taken around the running end itself or the knot will not tighten against the pull. To get a tighter hold on heavy poles for lifting or dragging, the timber hitch and half hitch are combined. The running end is passed around the timber and back under the standing part to form a half hitch. Further along the timber, a timber hitch is tied with the running end. The strain will come on the half hitch and the timber hitch will prevent the half hitch from slipping. A clove hitch is used to fasten the rope to a timber, pipe, or post. It can be tied at any point in the rope. To tie a clove hitch in the center of the rope, 2 turns are made in the rope close together. They are twisted so that the 2 loops lay back to back. These 2 loops are slipped over the timber or pipe to form a knot. To tie the clove hitch at the end of the rope is passed around the timber in 2 turns so that the first turn crosses the standing part and the running end comes up under itself on the second turn. A quick method for tying a rope to a timber or pole is the use of 2 half hitches. The running end of the rope is passed around the pole or timber, and a turn is taken around the standing part and under the running end. Doing this creates 1 half hitch. The running end is passed around the standing part of the rope and back under itself again. Another hitch used for fastening a rope to a pole, timber, or spar is the round turn and 2 half hitches. The running end of the rope is passed around the pole or spar in 2 complete turns, and the running end is brought around the standing part and back under itself to make a half hitch. A second half hitch is made. For greater security, the running end of the rope should be secured to the standing part. The fisherman's bend is used to fasten a cable or rope to an anchor, or for use where there will be a slackening and tightening motion in the rope. To make this bend, the running end of the rope is passed in 2 complete turns through the ring or object to which it is to be secured. The running end is passed around the standing part of the rope and through the loop which has just been formed around the ring. The running end is then passed around the standing part in a half hitch. The running end should be secured to the standing part. A sheep shank is a method of shortening a rope, but it may also be used to take the load off a weak spot in the rope. To make the sheep shank, which is never made at the end of the rope, 2 bites are made in the rope so that 3 parts of the rope are parallel. A half hitch is made in the standing part over the end of the bite at each end. There are numerous items which require lashings for construction, for example, shelters, equipment racks, and smoke generators. 3 types of lashings will be discussed here: the square lash, the diagonal lash, and the shear lash. The square lash is started with a clove hitch around the log, immediately under the place where the crosspiece is to be located. In laying the turns, the rope goes on the outside of the previous turn around the crosspiece, and on the inside of the previous turn around the log. The rope should be kept tight. 3 or 4 turns are necessary. 2 or 3 frapping turns are made between the crosspieces. The rope is pulled tight. This will bind the crosspiece tightly together. It is finished with a clove hitch around the same piece that the lashing was started. The square lash is used to secure one pole at right angles to another pole. Another lash that can be used for the same purpose is the diagonal lash. The diagonal lash is started with a clove hitch around the 2 poles at the point of crossing. 3 turns are taken around the 2 poles. The turns lie beside each other, not on top of each other. 3 more turns are made around the 2 poles, this time crosswise over the previous turns. The turns are pulled tight. A couple of frapping turns are made between the 2 poles, around the lashing turns, making sure they were tight. The lashing is finished with a clove hitch around the same pole the lash was started on. The shear lash is used for lashing 2 or more poles in a series. The desired numbers of poles are placed parallel to each other and the lash is started with a clove hitch on an outer pole. The poles are then lashed together, using 7 or 8 turns of the rope laid loosely beside each other. Make frapping turns between each pole. The lashing is finished with a clove hitch on the pole opposite that on which the lash was started. Almost any natural fibrous material can be spun into good serviceable rope or cord, and many materials which have a length of 12 to 24 inches or more can be braided. Ropes up to 3 and 4 inches in diameter can be laid by 4 people, and tensile strength for bush-made rope of L-inch diameter range from 100 pounds to as high as 3,000 pounds. Using a 3-lay rope of 1-inch diameter as standard, the following table of tensile strengths may serve to illustrate general strengths of various materials. For safety's sake, the lowest figure should always be regarded as the tensile strength. To discover whether a material is suitable for rope making, it must have 4 qualities. 1. It must be reasonably long in the fiber. 2. It must have strength. 3. It must be pliable. 4. It must have grip so the fibers will bite onto one another. There are simple tests to determine if a material is suitable. First, pull on a length of the material to test for strength. Second, twist it between the fingers and roll the fibers together. If it will withstand this and not snap apart, an overhand knot is tied and gently tightened. If the material does not cut upon itself, but allows the knot to be pulled taut and will bite together and is not smooth and slippery, then it is suitable for rope making. These qualities can be found in various types of plants, in ground vines, in most of the longer grasses, in some of the water reeds and rushes, in the inner barks of many trees and shrubs, and in the long hair or wool of many animals. Some of the green freshly gathered materials may be stiff or unyielding. When this is the case, it should be passed through hot flames for a few moments. A heat treatment should cause the sap to burst through some of the cell structure, and the material thus becomes pliable. Fibers for rope making may be obtained from many sources such as surface roots of many shrubs and trees with strong fibrous bark, dead inner bark of fallen branches of some species of trees, and in the new growth of many trees such as willows, the fibrous material of many water and swamp growing plants and rushes, many species of grass and weeds, some seaweed, fibrous material from leaves, stalks, and trunks of many palms, many fibrous leaved plants such as the aloes. There may be a high content of vegetable gum in some plants. This can often be removed by soaking the plants in water, by boiling, or by drying the material and teasing it into thin strips. Some of the materials have to be used green if any strength is required. The materials that should be green include the sedges, water rushes, grasses, and lianas. Palm fiber is harvested in tropical or subtropical regions. It is found at the junction of the leaf and the palm trunk, or it will be found lying on the ground beneath many palms. Palm fiber is a natural for making ropes and cords. Fibrous matter from the inner bark of trees and shrubs is generally more easily used if the plant is dead or half dead. Much of the natural gum will have dried out, and when the material is being teased, prior to spinning, the gum or resin will fall out in fine powder. Use any material with long strong threads or fibers which have been previously tested for strength and pliability. The fibers are gathered into loosely held strands of even thickness. Each of these strands is twisted clockwise. The twist will hold the fibers together. The strands should be formed 1/8 inch diameter. As a general rule, there should be about 15 to 20 fibers to a strand. 2, 3, or 4 of these strands are later twisted together, and this twisting together or laying is done with a counterclockwise twist, while at the same time, the separate strands which have not yet been laid up are twisted clockwise. Each strand must be of equal twist and thickness. Shows the general direction of twist and the method whereby the fibers are bonded into strands. In a similar manner, the twisted strands are put together into lays, and the lays into ropes. The person who twists the strands together is called the layer and must see that the twisting is even, the strands are uniform, and the tension on each strand is equal. In laying, care must be taken to ensure each of the strands is evenly laid up, that is, one strand does not twist around the other one. When spinning fine cords for fishing lines, snares, etc., considerable care must be taken to keep the strands uniform and the lay even. Fine thin cords of no more than 1/32 inch thickness can be spun with the fingers and are capable of taking a breaking strain of 20 to 30 pounds or more. Normally 2 or more people are required to spin and lay up the strands for cord. However, many native people spin cord unaided. They twist the material by running the flat of the hand along the thigh, with the fibrous material between hand and thigh, and with the free hand, they feed in fiber for the next spin. Using this technique, one person can make long lengths of single strands. This method of making cord or rope with the fingers is slow if any considerable length of cord is required. Equal thickness and twist for each of the strands throughout their length are important. The thickness should not be greater than is necessary with the material being used. For a grass rope, the strand should not be more than 1/4 inch diameter, for coarse bark or palm, not more than 1/8 or 3/16 inch, and for fine bark, hair, or sisal fiber, not more than 1/8 inch. There is a tendency with beginners to feed unevenly. Thin wispy sections of strand are followed by thick portions. Such feeding degrades the quality of rope. Rope made from such strands will break with less than 1/4 of the tensile strain on the material. Beginners are wise to twist and feed slowly. Speed, with uniformity of twist and thickness, comes with practice. Thick strands do not help. It is useless to try and spin a rope from strands an inch or more in thickness. Such a rope will break with less than half the tensile strain on the material. Spinning thick strands does not save time in rope making. Lianas and ground vines are natural ropes, and grow in subtropical and tropical scrub and jungle. Many are of great strength and useful for braiding, tree climbing, and other purposes. The smaller ground vines, when braided, give great strength and flexibility. Canes and stalks of palms provide excellent material if used properly. Only the outer skin is strong, and will split off easily if the main stalk is bent away from the skin. This principle also applies to the splitting of lawyer cane, calamus, palm leaf stalks, and all green material. If the split starts to run off, bend the material away from the thin side, and it will gradually gain in size and come back to an even thickness with the other split side. The fibers in many barks which are suitable for rope making are located near the innermost layers. This is the bark next to the sapwood. When seeking suitable barks of green timber, cut a small section about 3 inches long and 1 inch wide. Cut this portion from the wood to the outer skin of the bark. The specimen should be peeled and the different layers tested. Green bark fibers are generally difficult to spin because of gum, and it is better to search around for windfall dead branches and try the inner bark of these. The gum has likely leached out, and the fibers should separate easily. Many shrubs have excellent bark fiber. It is advisable to cut the end of a branch and peel off a strip of bark for testing. Thin bark from the green shrubs is sometimes difficult to spin into fine cord and is easier to use as braid for small cords. Where it is necessary to use green bark fiber for rope spinning, the gum will generally wash out when the bark is teased and soaked in water for a day or so. After removing from the water, the bark strips should be allowed to dry before shredding and teasing into fiber. One person can braid and make suitable rope. The 3-strand braid makes a flat rope, and while quite good, it does not have finish or shape, nor is it as tight as the 4-strand braid. On other occasions, it may be necessary to braid broad bands for belts or for shoulder straps. There are many fancy braids which can be developed from these, but these 3 are basic and essential for practical woodcraft work. A general rule for all braids is to work from the outside into the center. 1. The right-hand strand is passed over the strand to the left. 2. The left-hand strand is passed over the strand to the right. 3. This is repeated alternately from left to right. 1. The 4 strands are placed side by side. The right-hand strand is taken and placed over the strand to the left. 2. The outside left-hand strand is laid under the next strand to itself and over what was the first strand. 3. The outside right-hand strand is laid over the first strand to its left. 4. The outside left strand is placed under and over the next 2 strands, respectively, moving toward the right. 5. Thereafter, the right-hand strand goes over one strand to the left, and the left-hand strand under and over to the right. Potential IP should consider assembling and carrying personal survival kits. The shock and fear associated with some isolating events have caused IP to hit the ground running, leaving their survival kits behind. If IP have a personal survival kit in their pocket, it may improve their survival chances considerably. A great deal of thought should go into preparing personal survival kits. The potential needs of the IP must be a consideration, such as the impact of the environmental elements, type of mission, availability of recovery, and distance to friendly forces. There are 2 basic ways to carry a personal survival kit. One way is to pack all items into 1 or 2 waterproof containers. The other way is to scatter the items throughout personal clothing. Any type of small container can be used to encase the contents of the personal survival kit. Plastic cigarette cases, soap dishes, and even metal Band-Aid boxes are excellent containers. Examples of items which can be packed into a small container include matches, safety pins, varied sizes, fish hooks and line, knife or multi-tool, small, multi-bladed, button compass, prophylactic, for water container, snare wire, water purification tablets, signal mirror, needles with thread, Band-Aids, aluminum foil, insect repellent stick, lip balm, soap, antiseptic, super glue, duct tape. Thank you for watching.